So I feel a little bit bad about this because I think this poor little pattern didn't get much love this morning, early doors, and I was like, oh gosh, that's kind of the first slide. But, you know, a few years ago, this was all we were talking about, and it still works great today. That's the beauty of this pattern is in the simplicity of it. And I've given it the moniker classic serverless APIs, and classic is still a pretty good thing. But there's problems with it, right? And we saw this in Chloe's talk. Her case study talked a lot about the issues of that classic at scale. As more traffic comes in, more business requirements come in, more use cases come in, and your microservices start to expand and expand. There's a couple of ways that you deal with that complexity whilst staying in a single Lambda function. As Chloe mentioned as well, I'm going to be piggybacking a lot off of her talk, to be honest. If else. You get if else absolutely everywhere. The second way that I see quite a lot, and this is my least favorite way, is file-based abstraction. So you've got your single Lambda functions still, but to make that file a little bit cleaner, a bit tidier, you start to abstract to more and more files. So there's a few problems that are inherent with both of those ways of dealing with that complexity. It becomes very difficult to understand. The control flow is super hard to follow. Change becomes real risky to introduce. You can make introduce subtle bugs that have catastrophic effects downstream. Much slower to test and deploy, big bang releases, and very hard to recover from failure. If something goes wrong in one of those big if-else statements, everything's going to fail. So as Dave said, my name's Luke. My favorite thing about serverless is the community, and that sounds super cheesy. It sounded a lot less cheesy in my head when I was just thinking about that, but it's true. It's why I come to events like this, why I love speaking at events like this, and it's why we wrote the book as well, Serverless Development on AWS. We wanted to give back to the community, but it was super important for us to involve the community. So at the end of each chapter, we have a chapter expert, a subject expert. Dave was one, Jeremy, who spoke earlier, was another. And it was just to kind of make sure we had lots of different voices in that book, not just mine and Sheen's. Yeah, I'll be giving a few out later on, so come by and get one. Or buy one off Amazon. I checked earlier today, it's £41 on Amazon, so put that on expenses. All good. I think just coming off that tour, I don't know how you guys felt, but I just felt super inspired. And there was one bit that stuck out to me, and that was that they were always thinking 5 ships ahead. These builders, these engineers, these designers, they're always thinking 5 ships ahead. How can we innovate? How can we improve on each ship? And in that spirit of innovation, it applies to software engineering, right? We always have to look out for new things that we can incorporate into our architectures. Again, Chloe said, success lies in the adaptability of our architectures. But it's all well and good thinking about how you innovate. You've got to have a plan for how you adopt that innovation, how you adopt it incrementally. So a lot of my talk is going to be focused on migration. And Charity May just put it a little bit more brutally. If you aren't migrating, you're dying. And if it hurts, do it more. But sage words there. And I'll focus it a little bit. I'm not going to talk too generally. The migration we're going to be looking at is possibly one of the hardest migrations, right? Don't want to do things easy. We want to make it nice and challenging. So we're looking at a business-critical workload, something that people are using all the time, super high volume, right across the world, and something that's critical to the business. And specifically, we're looking at that synchronous API as well. So some aims when we're doing a migration like this. Obviously, there's the innovation side, but you've kind of got to tie that migration to something, right? You don't want to migrate, you don't want to innovate for the sake of it. There's lots of new shiny stuff out there, but if you can pin your migration plan and your design on something concrete, maybe that's cost savings, performance, like Marco was talking about earlier. For us in this case study, we're looking at how we modernize our architecture that's underneath that API. And kind of called it stealth migrations. The title of the talk is how to migrate without anybody noticing. So you could migrate your API and say to your users, hey, I got V2 of my API, come and use it, it's great. Or you could just change it without them noticing a thing. And that's super good for a number of reasons. Zero downtime, but also zero impact on those as users of your API. No changes on their side. And that's super good for them. No work. They get all the benefits for free. But it's also super good for you because, we've probably all built APIs. But the best APIs are one that people are using. And if you're relying on someone to adopt your API, that's probably going to take a long time for them to migrate. So if you want them to adopt overnight, this is how you do it. And of course, we want to maintain that service level, right? The whole idea is we're improving things here. We don't want to make anything worse, no regressions. So we're going to be talking about orchestrated services, and I hope you haven't heard enough about step functions quite yet, because we're going to be digging into that a little bit. So, the moment of truth. If API Gateway into Lambda was classic serverless, I'm going to go out on a limb and say modern serverless APIs are API Gateway into step functions directly, nothing in between. And remember, we're talking about synchronous APIs, that request and response model, so I won't go too much into asynchronous. And there we go. That little thing there, the step functions workflow, that's what I'm going to call our orchestrated service. And it kind of looks a little bit like this. So you've got your API call, that stays the same. It's a post request, it's got a little bit of data in there, and you drop into your state machine as you handle that API call, and then you start to operate on the inputs, right? You start to introduce a choice. You can kind of see how that links back to our if-else nightmare from earlier. We can go down different branches. We can handle this request in different ways. It's the same service. It's encapsulated in the same thing. You can test it, deploy it in isolation, all those good things. But your logic now begins to be separated out. It becomes a lot clearer, becomes a lot easier to reason about, becomes a lot easier to test and operate. And we'll go into those things a little bit. So whereas before, we were handling all that complexity, no getting away from that. Before, we were handling that in a single Lambda function. But now, we're going to put all that complexity into a state machine. And so you can model that logic as a workflow. Quite often with the teams that I work with, once we've been building out one of these orchestrated services for a while, and everything's kind of migrated over, we stand back and we look at it and go, whoa, what have we just done? That looks crazy. That looks insane. Like, there's so much complexity there. And you might have seen these state diagrams where they're absolutely massive and they've got all these branches and different services doing different things. And they do look complex, right? But that's because they are complex. The software we're building isn't simple, right? It's complex software. But with a state machine, with a step functions workflow, you can see that complexity. It's not buried anymore in if-else logic and loads of files. That looks simple, but it actually isn't. Here, the complexity has nowhere to hide. You can see it. And now, if you think it's overly complex, you've got that opportunity to iterate on it and change it. This is a big point. Point number 2 here, to utilize a compute framework. So that's kind of how I'm going to pitch step functions, as a compute framework. And we'll get into what that means a little bit later. But essentially, step functions gives you loads and loads of tools that you can use to perform your business logic, to describe your compute. it gives you the opportunity to consolidate microservices. You can imagine before you might have had a Lambda function per API Gateway endpoint. You can look at consolidating that and using that choice branching. And it allows your architecture to evolve at scale. We'll go into that in a little bit. So going back to stealth migrations, how do you go from classic serverless to modern serverless without anybody noticing? How do you do that? We're going to call on one of our old friends, the strangler fig pattern, which might sound a bit weird if you haven't heard it before, but I've done extensive research into what a strangler fig plant is, and they thrive in dense jungles and forests where sunlight is at a premium. They root themselves to the host tree and grow up around it so that they steal all the sunlight, effectively strangling and suffocating the host tree. Sounds pretty horrible, to be honest, but anyway, that's enough of that analogy. So, what does that actually look like? So step 0 is our classic API architecture, our API gateway into Lambda function. Now, step 1 on your migration path is simply to bring in step functions and just pop that little Lambda function right in the middle of it, nothing else, and set up your integration between API gateway and step functions. So that's the only change there, right? You're now calling step functions instead of Lambda directly. But underneath, it's still the same Lambda function, and it will still return the same response, and it will still accept the same request. And that allows you just to get a little bit of confidence with that integration. No one's noticing anything either at this point. There we go. Now, step 2. Obviously, we're taking this very gradually. Remember, we're talking about a business-critical API. We want to take this nice and slow. We don't want to, obviously, break anything. So here we have the original system on the right-hand side with the Lambda function. And what we've done now is we've introduced a choice state. So that's one of these out-of-the-box flow states. And that just allows us to put an if-else in there. It can operate on any condition, whether that's a static property or some dynamic variable that's coming in from the inputs of the API. But what we'll do at this point is we'll just have that choice, but it'll always evaluate to point down to the original system branch. So we'll have our new system in place, but no traffic will be routed to it. And obviously we can tweak these numbers in lower environments, but here we're talking about what would actually be shipped out to a user. And then the third step is to start routing that traffic to your new system. So the box with the 3 dots, the new system, we'll get into what that actually looks like, but essentially that's all your Lambda function logic ported over to be something native to step functions. So now we're starting to incrementally shift that traffic over. The old system's still there. It's still there if we need to fall back. But this allows us to really get our confidence in the new system in an incremental way. And that choice can be based on absolutely anything. It could be based on the market that the user's making the request from. Could be based on what day of the week it is. Could be absolutely anything. It's up to you. So there we go. And the fourth and final step, now that you've fully migrated your traffic over to the new system, you're very happy with it, you've hardened it and improved it, you effectively now remove that choice state, remove the original system, and there you are. You're left with your nice modern serverless API into step functions. So yeah, we'll go back to how we actually, I made that look very nice and simple and easy. Obviously, the reality can be slightly different. So the best place to start when you've got your Lambda function and you want to port that over to a step functions workflow, start breaking it into steps. Sounds obvious, but it's a case of just looking through your code, understanding where the key components are, the logic you want to bring over, the conditionals you want to pull out of there and make them a lot clearer. Start to break it into steps. And as you do that, there's kind of three elements that you really want to promote. So that idea of native states, so your choice states, pass, fail, parallel states. If step functions can do it for you natively, prefer that, right? So get rid of your if-else codes, if-else clauses, replace them with choice states. Direct integrations as well. So sometimes I might say use Lambda as a last resort. That's kind of the same thing here, right? If you end up with your list of steps that you've broken your function down into, and you think, oh, I still need to do some things with Lambda functions, see if there's a native step functions way of doing that. Try and end up without any Lambda functions in your workflow as much as you can. Step function now can even do HTTP requests for you as well. So and obviously like SDK calls into DynamoDB and EventBridge, things like this. There's very little reason for using Lambda functions these days with this modern approach. There you go. Obviously, if it still makes sense and you still need to use the Lambda function, absolutely go ahead. But operationally, you're removing all those headaches of cold starts, of monitoring your account concurrency, all those sorts of things. And if someone else can do it for you, if we can delegate that work to AWS, let's do it. Same goes for intrinsic functions. So these are step functions gives you little utilities. You can generate like unique IDs. You can generate hashes of data and operate on strings and arrays, all this sort of stuff. Again, if step functions can do it for you, definitely try and prefer that. So this is a very, very contrived example of a Lambda function. Just shoehorned every one of those examples in here. This is definitely not real code, but it starts to show you how you can replace your custom business logic with native step function utilities. And then we break that down even further, so you can see here how each piece of code would map to the resulting step functions workflow. The final point I'll make on the migration itself is that minimizing impact on users. So we really want to make sure that the request and response are the same. You can bring in schema-based validation. And key point here is resisting improvements. When you're doing a migration, make sure you split that improvement phase out. Do that later. Try and resist, because otherwise it's gonna complicate things. So I'll move on to reliability. Now you're doing a migration. Alice from GP talked about this earlier, building up trust. When you're doing a migration like this, you want that trust from the business to be there. But you also want this migration to go pretty smoothly, but also pretty quickly, right? You know, these projects typically won't generate tangible value for the business, so you kind of want to move them along very quickly. And a big part of that is your test strategy. You don't want to compromise on quality. You don't want to compromise on reliability. So getting your tests right is super, super important to that. And what we say with serverless testing is kind of like the shared responsibility model that AWS has, right? If you didn't write it, if you're not running it, don't test it. You're delegating the handling of your API request to API Gateway. Let them handle that. You're delegating your database and your storage to DynamoDB. Let AWS handle that. But what you can test, and what you should absolutely test, is the integration points between those managed services. And we always say the three things you need to test there is configuration. Does the thing exist? Does it point to the right ARN? Does it have permission? Are the IAM permissions and policies correct? And are the payloads going to be what you're expecting? And on the flip side, once we're running this thing, once we're operating it in production, is our observability. So we adopt a CloudWatch first approach to this. Of course, there's many different flavors, but this is what's worked in the past for migrations of this sort. We break that down into a critical health dashboard. You might have come across the RED method of doing that, requests, error, and duration. This is all about just surfacing those core metrics. Composite alarms can be really, really handy here. In this distributed system, you've now got loads of different steps. You don't really want to be alarming on each individual service's metrics. So if you've got this grand orchestrated service, just have a single alarm. Is this thing working or not? Is it doing this critical operation that we need it to do or not? And then dig into the child alarms as you go further down. Prefer traces to logs. It's a simple one to say, not so simple to set up. We obviously have a reliance on logs, but relying on logs with a step functions workflow, a setup such as this can be really, really difficult to correlate across those logs. We've had great success with using X-ray and distributed tracing generally on a system such as this. Custom metrics is a good one as well. So you've got those choice states that we mentioned before. If you want to see, is the choice state operating as you expect, you can add a custom metric as soon as you go down the choice branch, put a metric into CloudWatch, and you can see how your workflow's progressing down the different branches. Another neat aspect of step functions that allows that fault tolerance is aliases and versioning, so you can route traffic effectively across versions as you roll out and roll back automatically based on a CloudWatch alarm. One thing that I've written a lot about in the book is the serverless square of balance. Really, this is like a framework for reliability that ties those bits and pieces together. And the whole idea here is that you balance across each four of these quadrants. So you want your pipelines to be super quick. That means minimizing your tests coverage, but maximizing test confidence. It means having that real strong observability strategy, and it means recovering from failures automatically as far as possible. So the idea is you might reduce your tests down, which means you might ship more bugs. But hey, we always ship bugs. Bugs are absolutely inevitable. But if you've got good observability, you'll catch those bugs. If you've got good recovery, you'll recover from those bugs. And if you need to release a fix, your delivery pipeline is super, super quick. So you'll probably be able to fix it, catch it and fix it before anyone has noticed. And obviously, the best critical API work goes unnoticed. We're the unsung heroes of the software world. If we're doing a good job, no one says anything. But sometimes, just sometimes, we might make a mistake and ship a bug, and then that's when people notice us, which is a good thing because that reminds you that you're doing the important stuff. One thing I want to leave you with here today is this concept of an incident journal. So we're very much trying to normalize failure here, right? Things go wrong. It's about how we respond to those failures. It's about keeping calm and having a little bit of fun with it. All right. So some tools to take away today. Hopefully it's been useful. That idea of orchestrated services, see where you can fit those into your existing architectures. Looking at your testing, looking at your observability, trying to see how you can strike that balance, and the incident journal there at the end. So that's all I had. Thank you very much.